These power functions have odd integer powers. So we're going to take a look at the functions f of x equals x, which we've talked about before in 130a, that's just a line. G of x equals x cubed, and h of x equals x to the fifth. So the powers are 1, 3, and 5 this time. So to complete the table below and then graph these functions, we're going to have input values of -2, -1, 0, 1, and 2. Our output values are going to be determined by the functions g of x equals x cubed and h of x equals x to the fifth. So you're going to substitute in -2 for x, cube it, and come up with -8 as the output. Do the same for h of x equals x to the fifth. Put the -2 in to the fifth power. Now, if you're not familiar with using your calculator, now would be a good time to get that out. If you're going to type it in, make sure you use parentheses around the negative and the 2, and then raise it to the fifth power. And we end up with a -32 as our output. Substitute in the number -1 in parentheses cubed, and we come up -1. Do the same for -1 raised to the fifth, and you'll also come up the number -1. Substitute in the number 0. 0 to the third power will be 0 still, and 0 to the fifth power will also be 0. Notice these power functions all have that origin or 0, 0 point in common. If I plug in +1 and cube it, I'm going to end up with 1. 1 to the fifth power is going to give me 1, and then do the 2. 2 to the third, 8, 2 to the fifth, +32. Okay. So again, I'm going to graph on the calculator, and then we'll just kind of rough sketch it in here. Go into your y equals, type in x raised to the third power, and then go ahead and graph that. What you'll notice is the ends are going in different directions, whereas if it's an even power, we notice that both ends went up. This one, the left end is down and the right end is up. It's almost like a piece of spaghetti, sort of. If you threw it against the wall, that's kind of how it would land. All right, so let's see what x to the fifth does. So I've got x raised to the fifth power. Graph that. And notice it comes in a little closer to the y-axis. It gets, again, it's a little skinnier, all right? Or it's been vertically stretched up a little bit, it looks like, from x cubed. So if I were going to freehand these in, this would be my x cubed. Notice again, they went through the origin. And if I'm going to kind of freehand x to the fifth, it also goes through the origin, but it's a little bit closer to the y-axis. And that's my y equals x to the fifth. All right. So if I'm guessing what's going to happen to y equals x to the 1, that's just a straight line. But take a look at that. Let me pull up my calculator again and just type in y equals x to see where that's going to land. All right, and notice the left end is down, the right end is up here, and again, it's going through the origin, but it's not real close to the y-axis. I mean, it's just a straight line. So if we wanted to draw that in, it kind of splits the quadrant right there in half. That's our y equals x to the 1. So the bigger the power, the closer to the y-axis it gets. All right. Describe the general shape of these graphs. So if p is positive and even, we're just going to draw in a shape. It's a bit of a U shape. And if p is positive and odd, it's more of the ends are split. All right, left side down, right side up. All right, what features do these graphs have in common? Well, they both either touched or went through the origin or the 0, 0 point. So both had 0, 0 in common. Each graph either touched it and turned around or it went straight through it like the ones above here did. What type of symmetry do these graphs have? Well, let's go back to our even power. All right, just kind of, again, a rough sketch of it. There's our y-axis. Our graph here folded over the y-axis, so if it's an even power, like we saw on the previous page, we have y-axis symmetry. If you fold it over the y-axis, it'll land on itself. For the ones above here, though, if I fold this over, I'm not going to land on the graph on the other side. In fact, it's over here, across the origin, that I notice that I have a similar shape. If I folded it over the origin, coming this way around, it'll land on itself. So if it's odd power, we have origin symmetry. Notice how the O's go together here, odd origin. Okay. What effect does increasing the power have on the graph? In both cases, on this page and the previous, the bigger the power, the closer to the y-axis it got. It got, again, for lack of a better word, skinnier, all right? Or it came in closer to the y-axis. So it came in closer to the y-axis as the power got bigger. Okay. So it helps to kind of keep those shapes in mind. Even power, the ends were going in the same direction. Odd power, the ends were split. Odd had origin symmetry, even had y-axis symmetry.